Hi all, this video is about section web assignment section 3.3. So the first question is trivial. The keyword is how quickly, or you can tell it from the unit is dollars per day. So we know this is about the derivative. And for the next one, question number 2. Question number 2, we are given the function equation, the average ticket price. So T of f, the output unit is dollars, and T of f just means the average ticket price. And the input variable f unit is dollars, and f is the operating cost of the flight. So we know this function T of f, the output means the average ticket price, and input f just means the operating cost of the flight. So now let's keep reading this one. When a barrel of oil is $130, the operating cost to this airline is changing by $200 per dollar. So this one just means okay, when, for example, now our first function is T of f, and the second function is about the oil price. So let's see. Let's say the oil price is f of p. So now we have a function composition. So this part tells you when p equals to 130, the operating cost is the input variable of the first function T of f. The operating cost is changing by $200 per dollar. So actually that means for the second function f and p, df dp, when the oil price is $130, we know this one, the derivative, the rate of change is just $200 per dollar. So let's see, what is the question? What is the rate of change of the ticket price with respect to the price of oil? P is the price of oil. So this one just means what is the value of dt. So now based on these two functions, we can generate a new function T of f of p. And the question is asking what is dt dp when we are given the price is $130. So we can use the chain rule. That is just the dt df is just the dt dp just equals to dt df multiplied by df dp, excuse me. So the second one, df dp, we know the p is $130. And for the second one, even though we don't know the value of f, but it's okay because let's go back to the let's go back to the T of f. You can see here, this is a linear function. That means for a linear function, the derivative is a constant number. So actually that means no matter what the value of f is, the derivative dt df is always 0.9. So we know this is just the 0.9 multiplied by the derivative of the second part, which is given. Then we are done. So next, all right, next, number 3. Number 3, this is just dc dt, just equals to dc d. This is a c of x of t. So c of x of t, dc dt is just a dc dx multiplied by dx dt. Then what is dx dt? By using this one, we know what is dx dt. And what is dc dx? dc dx, we have this formula. But now, because the dc dt is a function of t, so we cannot have x on the right side. So that means even though you have an x, you have to rewrite it, transform x into t. Then we are done. So dc dt must be a function of t. Now it cannot be a function of x. We cannot have x there. And then similar, example 4 is the same question. Example 5. And the example 6 is example 6, 3, 4, 6. They are pretty similar. Then next, let's see example 5. Example 5, we are given two functions, s of u of x. So we know the new function conversation is s of u of x. So this one, what is s of u? U. Okay, so it's already there. Just read the question, then you may know what is s of u, what is u of x. And the question is how quickly we know it's about the derivative. How quickly will the sales for this company be changing when the value of x is 13? The sales is the first function. So the question is asking what is ds, what is right here? What is ds dx? Because the sales when with respect to x, so ds dx, we are given the x is just 13. So for this one, we just know we use d, because the function is s of u of x. We use ds du multiplied by du dx. But for this one, since we are given the value, the specific value, you have to plug in x equals to 13. So the first one is easy, du dx, x equals to 13. Then what about the second one? What about the value of u? So there's a similar example in the textbook, which is page 127, example 4C. So you can see actually they're the same question. For C, example 4C, dA dt, dA dv. How can we find the value of v? We by using the value of t. So actually for this one, you can, because we are given the specific equation u of t, u of x, so you can just plug in u of 13. Just plug this one in, because we know x equals to 13. Plug it in. Then the u of 13, for example, suppose u of 13 after you plug in, it is 10. So this is a number I make up. You have to calculate it by yourself. Then we know the value is just the u of 13, which is 10. So this is not the correct number because I didn't calculate for it. You have to do it by yourself. And so this one, du dx, x equals to 13. That means, okay, we know u of x. What is u of x? So the question now is, what is u prime of 13? This is an easy question. And then plug in the number. This is the number here. And then what about the first part? The first part, we already know the value of u. It's just u of 13. Yeah, the value of u is just the u of 13. So let's change it. Then, because we already know the s of u is right here. So what is the s prime of u? We already know that one. That is 0.25 multiplied by u square of u. Square root of u is u to the 1/2 power. So it is just 1/2 multiplied by u to the minus 1/2 power. Then this is s prime of u. Then we know the value of u, just plug in x equals to 13. That is u of 13. And this one is just this value. So plug it in, then we have this part, then we are done. Example 6 is similar question. Example 7. So this is also a trivial question. F of x, there's a similar question. If you don't know how to solve for this one, you can go back to check. Let me see. Page 128, example 6, section 3.3. So for this one, first x of 23, plug in a equals to 23. Then we have 33. So next, plug in f of 33. F of x is given, so f of 33 is right here. Then similar, df dA equals to df dx multiplied by dx dA. Since we are given the value of a is 23, so the value of a is 23. And what about the value of x? that means x equals to x of 23. And the x of 23 is just 33. So we know how to solve for this one. And the next one is if the derivative is if it's positive, then it's just increasing. If the derivative is negative, then it's just decreasing. All right, and feel free to send me an email if you still have any questions after you watch the video. All right, thank you.